Okay, great. All right, everyone, welcome to, today is Wednesday, the September 28th, 2016, in the Berkeley Emergent Space Tensegrities Lab. This is going to be our Introduction to NTRT seminar. My name is Drew, and I am going to be clicking through things for the next, hopefully, hour or so to show everyone just how NTRT works and how to run applications and some basics. There will be an interactive portion of this that folks can follow along with too. So first thing for everyone, we're open up in what we have here is the Best Lab server that some folks are on. First thing we're going to do, open a terminal window. Let's see, so I can give a brief explanation of what's going on here. So this is a Linux computer, and the terminal is the easiest way to navigate around in folders when using something like NTRT that involves commands, to run commands. I'll give a couple brief ones, the three big ones that we'll end up using today. The first one, ls, stands for list. If you type in ls and then hit enter, it lists the files in a directory. If you end up needing more information, the ls and then a space, and then what's called a flag, a dash, and then an L. So this would be ls-L. This is list with more information here, and you can see some more things. In this terminal, blue means a folder, and gray or white just means a file. So I'm going to go to where I have NTRT installed here, which for me is under repositories. So cd is a command to change directory. So you do cd and then a space and then the directory you want to change to. So out of these blue options here, I want to do repositories. This is where I'm keeping NTRT. So cd that and then hit enter. And then we'll do an ls again just to see what repositories I have. So I've already cloned the NTRT repository and I have run the setup scripts. So I'm going to go ahead again and change into NTRT sim and then hit enter. And we'll listen. We'll see what's going on here in the base NTRT directory. Folks before this will have run the setup.sh file and the install scripts and gotten ready. The first thing we're going to do is we are going to change to the branch that we have created for this tutorial. So git is a piece of software that is used to manage code. It's what we use for NTRT. The command is git checkout to check out a branch, and then we're going to do the branch name. And the branch here is NTRT underscore intro. Sorry. This is an expected error. We need to do what's called a pull first. So from the repository online in the cloud, we're going to need to pull the most recent code. So git pull, and you hit enter, and then okay, so it needs, this is something specific for me. Do other people get that box, or does this input just show up? Okay, cool, great. So now we're going to try and run that checkout command again. On the terminal, you can press the up and down buttons to scroll through commands that you just recently run. So I'm going to press up a few times, and then we're going to do git checkout NTRT intro. Great. So if everybody's here, we have now just changed to the intro branch. This has some of the files that we're going to end up using. I am now first going to go to a directory where we have a little script that we can all follow along with. So typing ls again, we can see none of these files have changed. We're going to go into the src directory. Src stands for source, so like the source code. cd src, enter. We'll do an ls again to look. There are a few directories under here. The one where we will be developing our code is under the dev directory. So I'm going to change again into dev. And we can now see that there is a folder here called intro skeleton. This one right here that I'm highlighting. So this is one that we have put together specifically for this seminar. In order to develop for this, we are going to copy this directory into a new one. So the copy command is another one, cp. -r means recursive, so this is a recursive copy, and we're going to say the first directory, intro skeleton, and then we're going to call it intro workspace, WORKSPACE. Okay. I'm going to slow down a bit for folks. So I'll wait here. We can do an ls again, and we can see now there's a directory called intro workspace. Skeleton, as we're using here, is a directory that has a bunch of the files that we'll be editing. So it's skeleton in the sense that we will be filling in all the other parts. It's just the bare bones right now. We're going to go ahead and I'm going to change directories into the workspace that we just created. So cd intro workspace. Oh, and one other nice thing. Under the terminal, if you hit the tab button, it automatically fills in a name if there's only that name. So if you type in like int, it'll tab to there, because there's two intro something directories, it only ends at intro. Then if I type the next character, say W, and I hit tab, it'll go to workspace. That's convenient. I'll do an ls again in here. There are a lot of files in this folder. The one that we will open up to start looking through all the instructions for the seminar is called NTRT introduction.txt. So the text editor that we can use to view things, you all might have different ones in your computer. The one that we'll be using in this seminar is called gedit. So we'll type in gedit and then this NTRT introduction.txt. So NTRT underscore introduction.txt. Now, when running a command that opens up a window, if you put an ampersand at the end of the command, that brings the window to the foreground and lets you continue to type commands on the terminal. So I'll do that, and you can see this opens up. Now, there's going to be, well, I guess I can do it this way. All right. So we've already passed through the preliminary part here. So, oh yes, one more command that I think is useful. I'm going to switch back over here by clicking on this top tab. The pwd command is print working directory. This says what directory we're in right now. The way that Linux does directories is with slashes. So you can think of this as something equivalent on a Windows computer to like C:, users, drew, you know, something, something, something. I'll wait for a moment. Brian, you got it. Shirley? Yes. Thanks everyone for your patience. You're all right, Asher? Yeah. Okay, cool. So I can go ahead and show that real quick. So let's go ahead and close this window. So if we did this without the ampersand, I'm going to hit the up arrow a few times to get back to that command. We'll do it without the ampersand. We'll switch back to the terminal, and you can see it's only like black here, right? That means that the terminal isn't taking any more commands. So in comparison, we close this and then run it with the ampersand. See, the terminal has the command line back, and now we can run more commands on it. So. Yep. So, okay. Great. I just copied. Yeah, we haven't changed anything yet. And then I went ahead and I ran this command to go ahead and open up this document. Everything. Okay. So we discussed terminal colors a little bit. So preparing. So we have switched to the introduction branch. We've copied over the skeleton. Yeah, so what skeleton means is code that is not completed. We'll have a couple of places in the code as we look through that I've written fill in, and those will be the places where you will actually write something. Okay. So now basic usage, great. So we can finally go ahead and get started. In NTRT, we will be accessing files with in multiple locations very quickly in very short window of time. So what I like to do is have multiple terminal windows open so that we don't have to like CD back. So as an example of what we might need to do, the dot, so CD space and then dot means to change directory backwards. So you can see now I'm just in the dev folder, and if I wanted to go back into intro workspace, I could do that. What I'm going to do is to create a few more terminal windows just as we end up needing them. So file, new terminal, it's also Shift Control N. So I'm going to do Shift Control N. It opens up a new terminal. And you can see PWD here. You can see what directory you're in. Now I'm going to change directory back a few layers. So CD dot gets us into the dev directory. CD dot again, or you can just hit up. Goes into the SRC directory. And then CD dot one more time, and we're in the base NTRT directory. I did this so that now we can change into the bin directory. So CD and then bin. And now I'm going to look here, ls. The bin directory is where we end up running the scripts that compile all the code. So colors in terminal, green means it's an executable file. To execute a file under the Linux command line, you do a dot and then a slash and then the name. So you can see here that we have this build.sh. That's the file that will compile our code. So build.sh, and then hit enter, and it will go through and compile all this code. It might take a while because there are many people on the server right now. So when this code compiles, when this build script runs, there's lots of output to the terminal here. Most of it you don't need to worry about. What will end up happening, if there's anything you need to worry about, there'll be an error. So at this bottom line, as opposed to 100% finished, it might say something like make failed or build failed, error something. So now that we've compiled the code, I'm going to flip back to the first terminal window I had. So again, up at the top here are these two. Let me go ahead and make one more terminal window. So right now we'll have 3 open. One will be for where we are under the source dev folder. Another one will be under the bin folder. And then this third one, if you could follow along with the commands to go backwards. So cd dot back into dev, cd dot back into source, and cd dot one more time to go back into the base directory. So from here, now we're going to go into the build directory. So if you've seen, so far we've entered 3 directories under this base one, 3 folders. SRC for source, that's where the source code is located. The bin directory, which is where the script to compile the files is located. And then this build directory is where the compiled files will be placed. So source, bin, and build. Under build, ls, you can see that it has the same structure as the SRC directory. You can flip back real quick to, let's see, this first terminal window. If we want, we could go back. You don't need to follow me for this part. I'm just going to illustrate a concept here. I'm going to go back a few layers onto the SRC directory and list. And we can look here. There's files called like dev, controllers, core, helpers, etc. And then under the build directory, we can see the same kind of thing. Controllers, core, dev, examples, whatever. So it's a one-to-one correspondence. Anything that is in source will be put into build once it's compiled. Now let's go ahead and run an example application. So under build examples are ones that people have made for a while. Some that we've done to help people just see how the simulator works. So cd examples, change directories there. Now we can look with ls again. An example that I like to run is the Super Ball example. That is the 6-strut tensegrity robot. So B-A-L-L. In Linux, file names are case sensitive. So that means that if I typed in capital B-A-L-L right there, it would say no such file exists. It has to be the correct lowercase. And now under here, we can see that there's another green file. the executables in NTRT, we try and name them starting with app. So app Super Bowl will be the Super Bowl application that we end up running. And like before, you do // and then app, and the whole name, APPSUPERBALL. Now I'm going to go ahead and wait here for a bit while make sure that everyone gets caught up. And this is a good excuse to play with the simulator. So you can click and drag things around. Some other nice tips here are the keyboard shortcuts. So if we click the spacebar, it resets the simulation. So spacebar resets, and you can click it a bunch of times. You can see it's just fun to reset. The arrow keys are tilt in both directions. So the arrow keys tilt, and you can see that we actually have the ground at an angle here. I'll talk about that a little bit later. But so arrow keys tilt, and then X and Z are zoom in and out. So X is what I'm typing here now that zooms out, and Z zooms in. One other button to press is the semicolon button. So if I hit semicolon, it'll zoom to right where the object is. And what will end up happening then, I'll press semicolon again, and the system will, the visualization will stay where it is, and then I can hit semicolon and it'll track. Now, semicolon, yes, it's next to L on the keyboard. Yeah, it's this button. Okay, great. So a quick check-in. How are folks doing? Marty, Michael, we need to wait? Okay. Take your time. No, this is totally fine. The people following along with us, well, yeah, it's totally fine. The people following along just get to go ahead and wait and play with the fun robot. I can go ahead and talk about some other things. Yes? They are infinity. So you can actually, we can zoom out a little bit, press X. The way that oh, sorry, what I meant to say, I didn't mean to say that at all. What I meant to say was that it can fall off to infinity. So if you take this thing, let me see if I can grab it, and flick it over. So you see the ground ends at a certain point, and now we pass below the ground. If you press the space bar, it zooms back to where you are. Yeah. That's fascinating. What branch are you on? Did you check out the right branch? So you can say, so a command to see what branch we are on in Git is git status. So that will say a few things. That'll say here on branch NTRT intro. That means that we're on that branch. And it'll also tell us what files. Are you on NTRT intro? So change into the bin directory and someone's to that. Yeah, and // Scroll up. Actually, run it one more time. Yeah. Scroll up. Oh. Following where using project, they're setting up. Oh Lord. Scroll a bit. Source directory. I have no idea what that error is. Yeah, I have no idea what that error is. Let's see. Let me just check and make sure that this still works on my computer. Yeah, so other folks are getting a weird error about CMake.
I've seen that happen.
Is
That
that
happened to Brian's machine earlier.
Okay.
It might be that you have to rebuild the whole system.
Okay, so this will be, so I'll do a command for everybody to follow along with if you do run into that error. So this is a weird error about the build script, or the build script, and it won't run. So from one of these windows, I'll change back to the base NTRT directory, ls again to see what's going on. You do /setup.sh, and that won't hurt anything if you already have it set up. So it should do all this initializing, but what it'll tell you if you get an error at any point in your NTRT installation, it'll tell you here where everything is built to. So these things like the bullet physics library is the underlying system that we end up using to do all the physics simulations, and you can see it's located in ENV. So things like NTRT sim ENV. So if we needed to rebuild things, what you would do is, oh my god, what just happened? My computer's in Russian. Okay. I don't know what happened there. Okay, that was weird. Okay. So if you needed to, say, do that, the way that you might end up doing it, if you go into the ENV directory, and then you would delete these files in here, if you needed to do that. Okay. So I'm sorry for the folks that can't follow along. We're going to keep going, though, and you can follow along later. So, build. Okay. Now I'm going to flip back. Now that we've run a file, and I'll go back here. Okay. So a couple other things. Documentation location. So documentation for the project is in two places. I'm going to open up a browser window, and the NTRT sim GitHub page. I'm sorry, this isn't as large a text. If you search under the GitHub, github.com, if you search NTRT sim here and press enter, oh, it's not, shouldn't be this repository. So if you were, say, from just github.com, if you search NTRT SIM, you can see that we have one result coming up here. You all don't need to follow along with this. You can just see how you might get to the documentation. Here's the main GitHub page for NTRT sim. If you scroll down, there are these links to documentation. So here's one link to documentation, and here's another one, these tutorials. So this is documentation of what each of these classes are, and then these tutorials about how to use some of the functionality. So that's where you would find documentation. And okay, cool. Now I will go ahead and we can look at an example application and what it needs. So I'm under the SRC directory again, and now we're going to go under DEV, which is where we were working before. So we can, everyone, make sure that you're here. And now we're going to go into the intro workspace that I created. You can say an ls. There are a couple of different files here. I'm going to do ls-l just to see everything a little bit easier. You can see that we have something labeled app, and if you saw before, that's what you ended up running. So the app file is what ends up getting compiled in the very end to run. This app file will call all of these other files that you end up having. There are a few others here. So there's these controller files that we'll talk about a little bit later. But in C++, you have a CPP file and an H file. So every class, as it's called, has its own H and CPP file. Those are two that are needed. In terms of components for an application, so we've got app, and then also a model in the older version of NTRT. We're going to be covering two different ways to use NTRT here. One is the older version that you build the models in C++, and the other one is the newer version that uses what's called YAML, YAML. So the components, again, application, potentially a controller if you want one, and then this model file. think that's what I wanted to say about that. Okay, great. There's one other, there are sometimes these other supporting files. Actually, every directory has this one called cmake lists. This is what tells that ./build.sh file where to, what files to compile. So I'm going to go back into the src or src dev directory. We can see that there's a cmake lists here. So we just made a new folder, this intro workspace, and we need to tell, or we need to put in cmake lists that folder name such that it will get compiled. So I'm going to do again, gedit is a way to edit text files, cmake lists.txt, and then I'm going to put an ampersand again. Great. And so now we can see that there's this window open with the cmake lists file. So I have here one of these fill-in spaces. So in my introduction, I say, yes, 4.1. So we will add the name of this directory, intro workspace, down here. You can hit enter, and then you can hit a tab. Apparently not. You can't hit a tab. You have to hit 4 spaces, I suppose, and type in then intro workspace. It should look like that. And then we can save. So file save, Control S. I'm going to be typing Control S just on my keyboard to save, and it'll probably just look like that. It might twitch a little bit. Save. I'm going to close cmake lists now. And then I'm going to switch back to the bin, wherever this was, yes, the bin. And then we'll go ahead and build one more time. And for folks who have this working, you can see that there's now more output. You can see, oh, hey, it built some of these apps that we were talking about. I'm going to switch back now to another terminal up here. Sorry. So I'll wait a moment. Okay. How are people? Okay. All right. So now we're going to look at the new files that were just built. So I'm going to go ahead and change directory back 2 dots again. This is now we're in the, out of these 3 terminal windows I have open. Ooh, there's something weird going on there. I'll press enter again. So this one was under the source code directory. This middle one I have here as the bin directory. This one, this third one here is where we'll be in the build directory. So I'm going to change directory ... to go back again. And then under build, we can type ls to see what's here. You can see there's a dev directory. Just like I said, because remember there's the same thing as src and build have the same structure. So we'll cd into dev. We can look again. We can say now there's this folder there, intro workspace, because code got compiled into it. I'm going to change into the intro workspace directory and list. So now we can see that there's one application here. I'm going to look back real quick into the, where was it? Okay. So under src dev, I'm going to go back into our intro workspace directory and look, and we can see that there's a couple applications here. You can see I have like an app 3-bar traditional and it's app 3-bar YAML, the 2 ways that we're going to be building files. The way I have this configured at the moment is that there's only one of them that's being built. So this app 3-bar traditional. This is some of the code that Brian and Ed wrote. Now, I'm going to go ahead and run this file. So /app 3-bar, need a capital B, traditional. When we run, and we see it falls over. So this one, the way I have it set up right now is that it's actually missing a cable. So we can press spacebar again and see that it resets and immediately falls over. So, oh no. we get to go ahead and add that cable back in. I'm going to close the window. In our introduction text document to follow along, yes, we just run app bar traditional. What happens? It falls over. So now we're going to fill in a line in the model file that adds this one actuator between the positions that it needs to be added to. So under the SRC directory, source dev intro workspace, we're going to open up this 3-bar model file, .cpp. The model files, the .cpp files, are where most of the code exists. 3-bar model.cpp and an ampersand at the end. Okay. So we'll open that up now. And this is what a model file looks like, NTRT. At the top, there's this big disclaimer, because we had to put that in for the lawyers. A lot of this is stuff that you will end up learning once you get more into it. I'm not going to try and explain most of this today. We're just going to go down instead to where we fill in our one line. The configuration here is where we set things like the density and the radius of the rods and change these numbers. Then there's just a bunch of supporting code. There are nodes that get added. This is a function that adds nodes in a specific location. Oh, this is something I should mention. So in NTRT, we have X, Y, Z directions, right? Just like in the real world. However, it's 3 numbers, right? First number, comma, second number, comma, third number. In NTRT, the Y coordinate, the second out of those 3, is actually in the vertical direction. So it goes, the first coordinate here, this, what I have here is edge versus 2.0 will be like in the X direction. This second 0 is Y, but that actually is the vertical coordinate. And then this third one is the other longitudinal coordinate. Now I'm going to scroll down a little bit more. We have a function here to add some of the rods. And at the bottom, here we go. So under the add actuators file, it looks like, according to gedit, I'm at line 220 here. So in C++ files, 2 forward slashes mean comment. So that means that a code will not get run if there's 2 forward slashes in front of it. So what I'll do here is I'm going to remove these 2 slashes. And then now I have to figure out what I want to fill in these 3 spaces here. So comparing it to these other ones, it looks like there's a number here, and then we're labeling it an actuator number. These numbers, these first 2, is a pair that correspond to the nodes that we've added previously. We have them labeled 1, 2, 3, 4, 5, 6. So in the introduction document, I tell us that we should connect nodes 3 and 5. And we would like to label that actuator number 5. So these 2, and then this number here. So I'm going to go ahead and fill those in. We would like to add a pair between 5 and 3. And then we would like to label it actuator number 5. You can see this looks now, it looks like these other files. You can see we have 0, 1, 2, 3, 4, 5, going all the way down. Yes, Karina? Nope, not at all. So this is actually an equivalent one. I'll do this just to show. I'll put 2, you all don't have to do this part. Well, actually here, never mind. I'll just go ahead and change them up. I have it as 5, 3, but you could also do 3, 5. These are equivalent. I'll save, file save. And what do I have next? Great, so now we're going to go ahead and build again. So now that we've saved this file, switch back to whatever terminal window I had under bin. Great. I'm going to hit the up arrow because that's easier than typing all of that in. I'll hit enter. It will go ahead and compile. And great. Great, 100%. Now I'll switch to the third terminal window, where we have, this is under the build folder again, ls, see. And now I'm going to hit the up arrow a few more times again, because I don't feel like typing in that long name again. And we'll run it, and it stands up. Hooray! There's an extra actuator added. You can see that it actually, none of the rods are contacting each other now. It's a proper tensegrity system. Another thing to take away from this, another observation, is that for a 3-bar tensegrity structure, it requires a minimum of 9 cables. So with one of those missing, with only 8, then the structure does not stand up. Okay. All right. How are folks doing? Does anyone need to see a command again? Okay. So at this point, we're running low on time. So what will probably end up happening here is that if you're having trouble following along, you can look at this later and then pause the video and fill in all the steps. I'm going to go ahead and keep going. Now, we have the, excuse me, we finished step 5.3. We went ahead and we built this app and the system stands up. Now, let's try and add one of those controllers. Right? So the system wasn't actually moving back then. It was just vibrating naturally based on the dynamics. But now let's have some of the cables move. So under this dev directory again, I am now going to again type gedit, and we're going to go into the app 3-bar traditional file. So the application is what contains the references to the controller as well as the model. So this is where we would add the controller in. App 3-bar traditional.cpp. And I'll put an ampersand again. Great. So now it opens up. An application file looks different than one of these C++ files, than one of the model files. I'm going to scroll down here. This is some stuff about creating the world, creating the ground specifically, setting up the simulation. Now here's the controller. Great, fill in 5.4 here. So I'm going to again delete those comment things. Now what do I want to fill in? I say over here the name of the controller class is called length controller. If you all saw the name of the file under, let's see, this terminal, you can see there was one called length controller. That's what we would like to create, one of these length controllers. So I'm going to switch back to the text editor window, go to the application, and for all these places where it says fill in, I will type in length controller. Note that there is an asterisk here. That is required. Do not delete the asterisk. So length controller and length controller. Great. Okay. I'm going to save. And now we can go ahead and try and build again. So I'm going to flip back to the terminal window that had been build. We'll run build again. I just press the up arrow. And this will recompile the file. Now after finished compiling, we'll switch back to the build directory, right? Because remember our 3 things: source, bin, build. And I'll run the application one more time. Push the up arrow. Now, you can see it's still vibrating a little bit, but it's not actually moving the way that we want to. So what the behavior we expect is for all these cables to move and for the system to wiggle around more significantly. So we can ask now, well, why isn't it actually going? Well, we created a controller But what actually needs to happen is that this controller needs to be attached to a model. So I'm going to click exit here. Now flip back to my little instructional document, NTRT introduction. And I can see here now 5.5, right? We expected it to move. Oh no, it didn't. Now, in the application, there is this line that we need to copy in. This my model points to attach thing. I will go ahead and type this in, and you all can, 1, 2, 3, 4 spaces. My model, a dash, and then a right greater than symbol, and then the word attach, and then an open parentheses, and then my controller, and then a close parentheses, and a semicolon. So we can see here, like my model, we can think, okay, well this is what we're talking about with this 3-bar model thing, right? The 3-bar model.cpp that we had up here, we're creating it as called my model. And then my controller is this controller that we're creating. And so we say model, attach, controller. I'll save this file again. And we'll repeat this process. Okay. I'm going to switch back here to the bin. I'll press the up arrow. We'll recompile. And now that it's compiled, I'll flip to the third terminal window, the build, right? Because we changed the source code. Then we built, and now we will run the file one more time. And what ends up happening here is a few seconds in, Brian's controller starts going. And so you can see that the structure is wiggling around a little bit here. It's crawling a bit. I believe Brian's length controller that he built pulls on each of the cables at a random length. So now we have a model that we had in an application and a controller file for it. Yeah, what's up? You'll have to ask Brian about that. We can actually look if we care. I looked at Brian's. This was a collaborative effort between Brian, Ed, and myself. So I'm going to look under the. Okay, so here's the dev folder again. I'm going to open up Brian's length controller and see if we can understand what it does. Length controller.cpp with an ampersand. And it immediately gets very messy with some random number things and not sure what's going on there and a bunch of this other nonsense. These are the things that you will learn how to do over the next year. So also Brian doesn't put comments in his code, and that's bad. Brian, you need to put comments in this code. So it looks like it does reset. So here's something about a toggle, Eric. You can see something about a toggle. Yeah, I'm going to close that because that's intimidating. All right, so I believe that's everything that I wanted to show folks for the way that structures are traditionally built in NTRT. Application, model, controller. I'm going to go and close these files real quick. This 3-bar model and the app 3-bar traditional. I'm going to close both of those because we won't need them. Now, for folks who are using the new structure that we're calling YAML, YAML, it is another programming language that is not C++, that is simpler to use, where you don't have to create all these classes and things like that. It'll be an easy way to create files or to create structures rapidly. So this YAML file will take the place of the model file. We'll still have an application and a controller, but a YAML file will be used instead. So yeah, so this is the changes. So first, we have to make sure that this new app is built. Under this terminal, so I'm going to do ls-l under the source dev directory, again, to see what's here. So you can see that there's this app 3-bar YAML that I have here as a file. But flipping to our build directory, we can see that there wasn't one here, right? There's only the 3-bar traditional one that's being built. That again is because we don't have an entry in the CMake lists file. So before, at the beginning of the presentation, we changed the CMake lists file for the dev directory. Now we're going to change it for the intro workspace directory. So you can see there's the CMake lists file here under dev intro workspace. I'm going to do, gedit CMake lists.txt and an ampersand. And again, things have to be the correct capitalization, so capital C, capital M, capital L. And now I have here these lines that we can uncomment. So in C++ files, a comment, code that does not get run, is 2 forward slashes. In CMake lists, it is a hash symbol. So we will delete the hash symbols in front of each of these. And we can see that it looks a little bit like this add executable command for the 3-bar traditional, right? But like I said, there's no model file, right? So there's a 3-bar model in this traditional version, and then there's no model file here. We just have the app 3-bar YAML, and then I have this controller. I'll go ahead and save this. Save CMake lists. I'm going to close that. We don't actually need to come back to the CMake list file, so I'm going to go ahead and close it. And what do I have as the next thing? Okay, so 6.1. Great. Okay, now we'll go ahead and compile. I'll switch back to the bin directory, press up, and hit enter for build. Now, see there's more. Aha, great. App 3-bar YAML, it was compiled. Wonderful. But, haha, we'll flip back to this workspace, and even though we can see that this app 3-bar YAML is here, let's try and run it. ./app3BARYAML. And we get an error. So, when running a YAML application, we need to specify what YAML file we would like to build, and I have a typo from this error message that I wrote a few months ago. So, as opposed to having the CPP model file, we have to have a new YAML file. For this, I'm going to open up a 4th terminal window, because I do not feel like going back and forth to this new location. I'm going to do open new terminal, Shift-Control-N. You can see we have 4 terminal windows up here. Maximize. The location of the YAML file that we will end up using is, I'll go back a few directories, go back into dev, go back into build, go back into the root directory, list to see where we are. We're going to go under the resources directory. So resources is the place where we keep a lot of these YAML files. So cd resources. We can look here and see there's a few things. Some of the other folks who do NTRT use these source and test directories for other stuff. We're going to be looking under the YAML structures folder. cd capital Y, lowercase AML, capital S, lowercase TRUCTURES. Right. In the list again, we can see some things. I have here a folder named NTRT intro structures. That's where I'm keeping the YAML file that we will be using. We'll change directory again, NTRT underscore INTRO underscore capital S structures. And now, so this is difficult to see, but I'll hit enter a couple of times just to try and clear out the terminal, but we're at such a deep directory that it's difficult to see. But lists has one file here, 3barmodel.yaml. So we need to pass this file in as an argument to the application when we run it. So we can see that it's under this repositories, NTRT sim, blah, 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 blah. I'm going to type in pwd, print working directory. That says exactly what directory we're at. I'm going to go ahead and copy this directory, or copy this string here, because I don't feel like typing in the full directory to get to this file, so I'm copying that. I'm going to go back here. We're going to do ./app3bar YAML, and then now I'm going to paste that in. Paste. So this big long thing. You could write this out, you could type it out if you wanted. I don't want to. So this is the folder. Now we have to specify the exact YAML file. I called it 3bar model.yml, I think. Let me check and make sure. What did I call it here? 3bar model.yml. Great. So this is what your command will end up looking like. It's long, I know, but ./app3bar YAML, and then this big long string of characters to exactly where the YAML file is located. Now, I'm going to run this, and it opens up. And similar to the other one, we're missing a cable, intentionally. You can press spacebar again and have it reset. You can see that the structure falls over. Great. So now, in the interest of time, I'm going to continue forward. Looking at my outline document here, you can see here, okay, so now we went ahead. This is just a bunch of text for 6.3. So we noticed that the structure is missing a cable. Let's fix that. So we're going to edit the 3bar YAML file. So under our fourth terminal window up here, we're going to again use the gedit command to open the file. And then the file is 3bar model.yml. I'll type in ampersand. Now, a YAML file is much simpler than a model file. If you scroll up and down, it's relatively short in comparison to the C++ file. And it makes a lot more sense. We define 3 nodes, and it's just in simple coordinates, your x, your y, which you remember, again, this is the vertical coordinate, z. And then we define, okay, so between this node and top 2, it looks like we'd like a rod, prism rod. And I've defined a couple of strings here and vertical strings. So it looks like there is one string missing. Similar to CMake list files, in YAML, a comment is a hash sign. So to uncomment a file, or to uncomment a line, I'm going to delete the hash sign. So now I need to know what nodes we should fill in here. Under the NTRT intro document, I think I say, yes, okay. I want to attach node bottom 1 to top 1 with this cable. So under 3bar model, we'll type in as the first one bottom 1 and the second argument top 1. Similar to the earlier question about if order mattered, the order does not matter for this one either. We could easily do top 1, bottom 1. It's just 2 points that are being connected. I'm going to save this file. And now, one of the nice things about YAML is that we do not need to recompile the entire simulator. This file, this YAML file, is not compiled. So under the terminal window, this is the build directory. So switching back to the build directory, if I just hit up one time here, not needing to run build.sh, but it refers to the same YAML file here. I'll hit enter, and now we have a structure that has an extra actuator in it, that has this vertical cable. So, hooray. This 3-prism model is a little bit different from the other 3-prism model. I think I calculated the dimensions slightly different than Brian and Ed. But you can pick this one up, move it around, spacebar resets, just like before. Great. Finally, we would like to have a controller for YAML. So my outline document here, introduction, Yeah, so again, no need to recompile, just run the application again. Okay, so similar to the traditional method, we will be editing the app file to add the controller in. Under our dev directory, right, this is where we have this app 3bar.yaml.cpp. I'm going to open it, gedit app 3bar.yaml.cpp, put an ampersand. Now opening up this one, it looks similar. This app file looks similar to the traditional app file. And there's a slightly different thing here. This is where the difference comes in. This is where the YAML file is entered in, if anyone's interested. I have built a slightly different controller than Brian and Ed here. The controller that I built for this test takes in a start time when we would like the controller to start, the percent length that we would want to get the cable down to. So this is 70% of the total length of the cable. And then rate, this is like meters per second, how fast the cable should be retracted. So this controller file starts at time 5 and retracts the cable at a rate of 0.25 meters per second until it gets down to 70% of its original length. So here, again, we have fill in. Now, again, what is the name that we need to fill in here? It looks like, what did I call it? I called it length controller YAML. The name of the controller class is length controller YAML. As opposed to length controller, we're going to write in length controller YAML. And I fill in over here. Length controller YAML. So Ed and Brian's controller, you might have noticed there was nothing here in between these parentheses. That means that there were no arguments passed in. For this controller, there are 4 arguments passed in. I've also said here that tags to control means what labels we would want to control here. We're controlling horizontal strings. If we flip back to the 3-bar YAML model, we can see that the label here, horizontal string, all of these horizontal strings that we've defined will be acted upon by this controller. We've written horizontal string. Now, because we've edited a CPP file, we do have to recompile the simulator. So for YAML files, you do not need to recompile. For CPP files, we do need to recompile. I'm going to save, and then switch back to our bin directory. Here we are. I'll press the up arrow, and we'll run build.sh one more time. This will be the last time we'll run it. We're almost there, everyone. Great, so that is executed. And now, if we go to our build directory here, I'm going to hit the up arrow one more time to have this long, difficult to type in command. And I'll hit enter. And now, if everything works right, after about 5 seconds, all of these horizontal cables, these ones that are in plane, will get pulled in. So my controller also spits out a bunch of information. Oh no, haha, I know what we didn't do. Can anyone guess what we forgot to do? Remember, there are 2 steps with the traditional model. We had to create the controller, and then we had to attach it to the model. So close this, and we'll do the exact same change in the app file. So switching back to this app 3-bar YAML file, yeah, exactly. So attach the controller to the model. I forgot. Now, we named the controller my controller also, and the model is still named my model. So the line that we're going to write here is going to be exactly the same as the one before. My model dash open whatever this character is, attach, open parentheses, my controller, open parentheses, semicolon. And now we'll save. I'll flip back to the bin directory. We'll build, and this is the last one, I promise. Now we will be done. I'll flip back to the build directory one more time. Oh, that's not the right one. Build, press the up arrow, we will run, and then now, at 5 seconds in, the controller should end up working. My controller, I spit out a bunch of nonsense information to the command line to show that it's running. So now we can see all of these cables at the bottom are getting tighter, and the structure should be standing up a little bit taller, and then eventually it should stop unless I've made a mistake. We might have the opportunity to do one more edit if we want here. Okay, so it looks like this. What's happening here is my controller is never reaching that final length. Oh, no, nope, it did. Great. Okay, cool. We could probably set that length to the rate to be a little bit quicker. Maybe 0.25 meters per second was relatively slow. So now we can pick it up and move it around again. We can see that it's very stiff now that these cables are shorter. And that's all my introduction. That is everything that I hope to show you all. So let's see, let me make sure that's everything here, my introduction document. Oh yes, so some extra features. Great. I'll really quickly, everyone can relax now. I am just going to go ahead and show everyone a couple quick, cool features. Terrain, I guess I probably won't have time to do markers, but I will try and do some data logging, and then I'll just show where some of these extra features are, DT and scaling gravity. This will take 5 minutes. I promise we can make it. Let me go ahead and I'm going to switch to another branch. So git checkout. Ground force sensor is the branch that I've made that has, okay. So what it wants me to do is to commit the changes that I've made here to this branch. I'm not going to. We can talk a little bit about Git later and how you might end up using Git. I'm going to reset all the changes I just made because we're done with the seminar anyway. So the command for that is going to be git reset -- hard head. So head is what the folder structure looked like before. Reset -- hard means delete everything that wasn't there before. Great. And now I can do checkout. Okay. So this is under my bin directory. While that's building, I am going to look and see where I put these files. So I put this under dev, ultraspine, horizontal spine. Okay, yes. I called it app horizontal spine. And then the YAML file for this, I think I put it under source, dev, ultraspine, horizontal spine. I called it tetrahedral spine dropped. That's what I called it. Working directory. Copy that. Okay. So this is where our executables were on our build directory. I'm going to go to the ultra spine directory here where I have horizontal spine. Now I'm going to run app horizontal spine, and if everything works, this should go ahead and paste. So Shift Control V is a shortcut for paste. Ooh, oh no. Okay. Well, horizontal spine, tetrahedral spine drops.yaml. And here we are! Oh, that's wonderful. Okay, so here's an example of some other stuff that you could end up doing. I have these little force plates that I made, and a controller similar to the one that we just used should start at some time, maybe. Well, either way, this is, okay, so the structure's falling over there. Let's figure out some other fun stuff to do. What's another nice example? So, examples. So that one also had data output. So if you ran that file, There should also be some information there about how to take data using what's called this. It's called TG data logger. And finally, one last thing that I'll show everyone is how to change the time step dt and how we would scale gravity if we needed. So in the app file, towards the top of this app file, this app horizontal. I didn't even rename it. You can see that I changed this for. This is the app3bar YAML.cpp file. I forgot to rename it inside here. This because I copied this earlier from the other version. So there's two places here to look. Time step physics. So right here looks like it's line 71. Time step physics is the DT for the simulation. This is the time step separating, or the time separating two sequential time steps in the bullet simulator. One thing that would end up happening here, let me see if I can actually do this real quick. If we have it too small, let me change it. What? No, sorry. What I meant to do is gedit. I'm going to change this time step to be not as large. And what we'll see after we recompile under here is the simulation will crash. At least it should, based on what I have here. Sorry, I'm not in the right directory. Dev, ultra spine, horizontal spine. Yeah. So you can see what happened with a slightly lower time step. What ends up happening is that everything goes crazy. So we can interpret this by saying that the simulation is unsteady. It does not converge when the time step is too large. So that's the big thing to take away from that. Change it back now so I don't forget. Put an extra 0 there. And then gravity. If we needed to change any scaling, one of the things that is talked about a little bit in NTRT, one of the other ways that things could go unstable besides having too large of a time step here is to have gravity, is to have your structure be too small. So one of the things that we can do is if anyone has done like a fluids class, for example, or a heat transfer class for any of the mechanical engineers, if you remember dynamic similarity, all these like non-dimensional numbers, like if you remember we keep the Reynolds number constant, then the flow is the same in these two situations. There's a similar thing that we can do in here. So setting gravity to 98.1 means that we can make all the structures twice as long and dynamic similarity is kept. So, or twice as large, 10 times as large. Yeah, sorry, thank you, Brian. 10 times as large. So you can think about all these lengths now being in like decimeters, I think. Yeah. Okay, and that's everything I had here. Those were the rest of the features. Thanks for listening.